Hello there. Today we're going to look at 7.1, ratios and proportions. It's not a lot of geometry stuff today. It's kind of getting us ready for what we need to do in geometry. Ratios, first of all, let's make sure it's just a comparison of two quantities by division. We'll typically write it with a fraction. You can kind of write it with a colon, but we rarely do that as we use it in math. We're going to write it like a fraction. All right, so here's an example of what I mean by it. You're going to set up some sort of a ratio. It says the bonsai bald cypress tree is a small version of a full-size tree. A Florida bald cypress tree called the senator stands 118 feet tall. What would be the ratio of the height of your little miniature bonsai to the height of the senator tree if the bonsai tree is 15 inches tall? So we're trying to compare this little bonsai tree to the full-size senator tree. And they're kind of tricky here because they gave those to us in different units. The senator tree was 118 feet compared to the bonsai that's measured in inches. Okay, that's not fair to compare these two numbers unless their units are the same. My very first step is to get the units to be the same. And I'm going to typically go to the smaller unit, so I'm going to leave my 15 inches alone, but the 118 feet, I need to convert that to inches. And there's 12 inches in a foot. So I would have to take my 118 feet times 12 inches, and then I would have my total number of inches. So 118, let me grab my calculator. 118 times 12. All right, so that's ultimately 1,416 inches tall, the senator tree is. Now that my units are the same, I could actually compare these two trees. It says set up a ratio and reduce if you can. Now it's important to set it up in the order that they ask for it. They said, what is the ratio of the bonsai to the senator? The bonsai is 15, so that goes on top of my fraction. 15 compared to the senator, which we just learned is 1,416. So that's the ratio. All right, if you want to reduce it, that would be good. I know 5 does not go into 1460, but maybe 3 does. I don't know. Let's try. 1416 divided by 3. Oh, it does go in there. All right, so I could divide these each by 3. So if I divide that by 3 and divide that by 3, I end up with 5 over 472. And then that is the ratio of the bonsai to the senator. So the senator, quite a bit larger, almost 100 times bigger. All right, so this part, now we're going to divide a quantity into a given ratio. So it says here the measure of two supplementary angles are in the ratio of 1 to 4. All right, what are the measures of the angles? Now here's what I was talking about. You can write a ratio as a colon, so that's how you're going to see it there. Now a 1 to 4 ratio is just a reduced version of the actual angles. Like it might instead be a 2 to 4 ratio. Maybe that's what it was, 2 to 4. Like one angle was 2 and the other angle was 4. And it just, I'm sorry, not 2 to 4, 2 to 8. 2 to 8. Just doubling those numbers. But 2 and 8 are not probably likely angle measurements, nor if I tripled that ratio, it'd be a 3 to 12. That's just another way to write this 1 to 4 ratio, but it just isn't a reduced version. It might be more likely, it might be 10 times that. So if I did 10 times that. So it was reduced, so it would be a 10 and a 40. It still reduces to a 1 to 4 ratio, maybe more likely angle measurements, 10 degrees and 40 degrees, but that still doesn't make sense because they're supplementary. Ultimately, what I'm going to do is I'm going to take my 1 to 4 ratio that I have, and I'm going to think of it as, okay, it was either doubled or tripled or times 10 or even more than that, but I had to take my 1 times something and my 4 times something to keep that ratio. But the other thing I know is those two angles that I have are going to have to add up to 180. So that's what I set up, a little equation. The 1x plus the 4x that I have is equal to 180. And that just simplifies to 5x equals 180. Divide by 5. X ends up being 36. Okay. So x is 36. So it wasn't double that ratio, or triple. It was actually 36 times that. The question says, what are the measures of the angles? So in my ratio, my 1:4 ratio, if I plug the 36 back in, the first angle was a 36, and the second angle was whatever 4 times 36 is, 144. So my two angles, the first angle is 36 degrees. The second angle is 144. I just took the 36 times 4. All right, let's try that again, but we're going to even make it fancier. Now it's an extended ratio. So you can see in my ratio I have 3 numbers all caught up in this ratio. The lengths of the sides of a triangle are in the extended ratio 3 to 5 to 6. The perimeter of the triangle is 98. What are the lengths of the longest side? So you've got some sort of a triangle here that's in a ratio of a 3 to a 5 to a 6. But again, I can double them or triple them or take them times 10 or whatever. So I'm going to take them each times x. And then I know the perimeter is supposed to be 98. Perimeter, I just add up the sides. So I'm going to go 3x plus 5x plus 6x. All needs to add up to 98. I'm going to end up with a 14x equals 98. Divide by 14. X goes in there 7 times. All right, now 7 is not my answer. The question is, what's the length of the longest side? All right, so ultimately all the sides would have to be times 7, but they just want the longest side, which would be the 6x. So I would say the longest side is equal to 42. And do we have units? Yeah, 42 inches. All right, this one's for you to try. Can you do that same idea? Set it up. It looks like it's a triangle again, and they're giving me the perimeter. You try this on your own. Pause the video right now. Come back when you're done. Here is my answer. I set up a similar equation, set it equal to 60, went and solved for x. Take your x value, that's your scale number, and you're going to take it times all of your numbers from your ratio. That's where I got my answers here, and then they were measured in centimeters. All right, let's go ahead and move on. This one says, use cross products to solve a proportion. Well, we're dealing a lot with these fractions and these ratios, and if you set 2 ratios equal to each other, it creates a proportion. So I have this ratio 9/2, I'm setting it equal to a over 14. And typically what we'll have is some unknown that we're looking for. And to solve that proportion, we do what we call cross products. Product means we're going to multiply across. So you're going to take cross products this direction and set them equal to cross products this direction. 9 times 14 is going to end up being, I should know that, 9 times 14, 126. Equals, cross products the other way, 2 times a. Divide by 2 because you're solving for a, and I get a to be 63. So you've solved the proportion. Now that's a very basic proportion because everything's just like a single number. Let's look at b here because all of a sudden we have this binomial sitting in here. That's a little trickier. Still going to do cross products. 15 times m equals, it's just that when you do cross products this way, you're going to have to think of it as 3 times m plus 1. And that 3 is going to have to distribute through the binomial. And now we just go through and we solve. So I'm going to move my 3m over here to the other side. 12m equals 3. Divide by 12. Be careful here. It's not 4. It's actually 1/4 is what that would reduce to. Now when we do those cross products, that's really key that you understand that for a proportion, there's different ways to write a proportion, and as long as you can keep your cross products to be the same, then the proportion is valid. So in this first example, so I've just got some ways that you could rearrange it. Right here, let's say I have this. Notice that the cross products are A times D equals B times C. Look at what I've done. I've flipped it upside down. Instead of having A over B, I put B over A. And as long as I do it on the other side also, the cross products still end up being B times C and A times D. So it's okay to flip that upside down. You're still going to have the same proportion. Right? Another way, and again, any way that you can rearrange it and keep those cross products the same, you're good to go. What I've done here is instead of, okay, so I wrote A to B, right here I've got A to B, C to D. Look at what I changed. Now I went A to C, so it's almost like I'm going left to right. A to C equals B to D, left to right. So you could do that because the cross products stay the same. All right, this one's a little fancier. It says add the denominator to the numerator. And so this would always work where if my denominator is B, obviously here, then if I add that to my numerator, A plus B, still put it over B, that ratio is going to be the same as if I do the same thing on this side. Add the denominator in, C plus D over D. Well, so that's a different type of scenario, but those ratios stay the same. Now let's see if we can kind of use those different options. All right, in this example here, it says in the diagram, they've got it marked to say that the ratio of x to 6 is going to be the same as the ratio of y to 7. Okay, that kind of makes sense. This little part to this big, little part to big. Got it. What ratio completes the equivalent proportion? All right, now they're going to change it up. They're going to say x to y. Okay, that's what they got. X to y equals, well, you want to keep your cross products the same. Common sense kind of tells me I think it's going to be 6 to 7. Will that work if I put a 6 and a 7? Check the cross products. X times 7, yep. 6 times y, yep, works. Got the same cross products. So your answer is 6 over 7, and that's how you would enter it into Math Excel. Just finish out the proportion. Okay, so this one, see if you can figure this out. What would the fraction need to be to keep it equivalent to this one right here? All right, pause the video, you try these two, and then come back to me. Here are my two answers. I knew that I needed to take the 6 times the y, so over here, 6 times the y. I had to take the 7 times the x. Got it. Okay, and the second one was the weird one, that I knew the way that this was set up, I had to use that third method where you take and add the denominator. That's all they did here, is they added 7, which was the denominator. All right, can I clean that up a little bit? Get rid of some of this. You can see in this first fraction, they had a y over 7, and they added the 7, added the denominator in. So that just means over here I had to do the same thing. I have to add the denominator to my numerator. So I have x plus 6 over 6. All right, hopefully this goes pretty quick for you. Good luck.